1.1 Lesson: Functions, Domain, and Range. What's important here to note is that in functions, domain, and range, we have to know what what the words mean. Domain represents the set of all values for which the independent variable is defined. That is, all the x values. Now, range is the set of all values of the dependent variable. That means these are determined from the domain. That is, the y values depend on the x values. That is why they're called the dependent variable. So the y values represent the range, and the x values represent the domain. Now, this is critical terminology that we use throughout this course, so you have to understand when I ask for the domain, we are looking at the x values. When I ask for the range, we are looking at the y values. Next, function is a relation in which there is only one value of the dependent variable for each value of the independent variable. What that means here, folks, is that we need to understand the definition. A relation is anything that can be graphed. So a set of coordinates, a mapping diagram, an equation, even a graph is all known as a relation. So anything graphable. A function is actually a special type of relation where there is only one value of the dependent variable for each value of the independent variable. Let's look at another definition. Definition number 2 says for every x value, there is only one y value. Now this is my favorite definition because it's straightforward. You check all the x's to see that they have only one y value. That means you can't have the same x with two different y values. So this definition is my favorite one because it defines this in a short and easy way to remember. Now definition 3 is used primarily for graphs. Okay, and we use this definition for graphs only because it talks about something called the vertical line test. Definition 3 says that a function is defined when it satisfies the vertical line test. That is, it passes the vertical line test. Now, let's look at an example. But before we begin looking at these examples and understanding domain, range, and functions, we start with the word relation. As I mentioned earlier, every graph, or anything that is graphable, every equation, and every table of values is a relation. Only special types of relations are functions, and those functions satisfy the definition mentioned on the previous page. Now, the definition is for every x, there is only one y. That is, every x, can only have one y value regardless. The domain and the range, the x and y values, can be expressed one of two ways, using set notation or interval notation. In grade 11, we discuss set notation. In grade 12, we do interval notation. Note that interval notation will be discussed in this lesson but not tested upon because set notation is the first type you're going to learn. Oftentimes, though, interval notation is just a way to understand it far easier than it is to use set notation. Next, examples of set and interval notation. So looking just strategically at a number line. So think of it only as the x-axis we're looking at. And given a set of numbers, keeping in mind that if you were to draw a number line, I want no less than 6 ticks here, 6 numbers here, 7. 7 ticks, can be more but not less than 7. And the reason why is you want to make sure your number line has a healthy set of numbers to be able to really see what is going on. So let's look at this example of a number line. You have a closed circle above the -3, closed meaning solid circle, okay? And then the line is going in this direction, and if you look at the numbers, these numbers are all bigger than -3. So we represent this in set notation by saying the following. Here is the set bracket over here, so it's a bump, a point, and a bump. So this is called the set bracket that you start with. And because this is the x-axis we're looking at, we use x as our variable. X belongs to. Now, what kinds of numbers are all of these? Well, some of you might be saying, well, that's integers. Not really, folks, because we also have to include all the numbers in between here. That includes every fraction, every decimal, every rational, every irrational. To do that, you have to understand that we are looking at real numbers. The reason they are called real is because they represent all the possible numbers that are graphable. So real numbers are the numbers that are graphable. X belongs to real, such that. So this represents such that. Again, this is a mathematical speak here, where this represents how to understand what is being expressed on this number line in set notation. X belongs to real, such that x, the variable that we're looking at, all the numbers on this number line, this blue number line up here, are greater than or equal to -3. So x is greater than or equal to -3. That is set notation here. Now, interval. So set notation, it's greater than or equal to, meaning that this was a closed, colored-in circle, and it's going in this direction. So that's greater than or equal to -3. Now let's recap what this means. This means x belongs to all real numbers. The big line there. Okay, what exactly are real numbers? So we're going to do a little recap as to what exactly all real numbers are, and they are as follows. N, you naturally began counting with your numbers, with your fingers, and using numbers 1, 2, 3, 4, 5. So everyone began naturally counting on their fingers. So N represents the world of natural numbers. W represents the world of whole numbers. That is, it begins with a 0. 0, 1, 2, 3, 4, 5. Natural numbers 1, 2, 3, 4, 5, and so on. Whole numbers 0, 1, 2, 3, 4, 5. And then we go on to integers. Integers is a Z. Think of this middle piece as the I that's been slightly tilted. Z represents the integer values, so that means the negative and the positive whole numbers, negative and positive natural numbers. So integers include all of these. Next, you were introduced somewhere along in your number career was rational numbers. Rational numbers are all numbers that can be expressed as a fraction. There are, in fact, numbers that can't be expressed as a fraction. That is, Q bar represents all the irrational numbers that Q with a bar on top represents the irrational numbers. And finally, this one represents all real numbers, that is, all numbers that are possibly graphable, and here they are, all real numbers. Okay? So, why we use real numbers? Because all of these numbers are represented by real numbers, and that is, when we look at this, x belongs to real numbers, that is, every number that is found in between here and here, including all irrational, rational, integer, whole, natural. All of these numbers are located in real numbers. And that way we can make a solid line and cover every possible number between -3 all the way up, going on forever to infinity. Now, x belongs to real such that x is, again, one more time, we're including the x, so there is an extra bar. X is greater than or equal to -3. X is greater than or equal to -3. So that's what this is stating. Now, noting this, remember that set notation always begins and ends with the same set of brackets. Begins and ends with the same set of brackets. Moving on, the next part that we need to look at is the number line, where you have the number line, same number we had where -3 was a solid circle moving in this direction, and we're going to introduce the concept of interval notation. Interval notation is a little bit easier to understand because you begin it with x belongs to, because again, we're looking at the x-axis, so x belongs to, and we're looking at where it moves from left to right. From the leftmost side, it is at -3. The rightmost side has an arrow. This arrow means it is going on forever. What number represents forever? That is the infinity sign. So x belongs to, now we have a square bracket at -3. The reason we have a square bracket is because it's closed. The circle is closed. We have a square bracket to represent closed. Now we go to infinity. Infinity does not stop. It is not a number, it's an idea. The idea that it continues on forever. So infinity will always have a round bracket. Always. Whether it be positive infinity or negative infinity, it will always have a round bracket. So again, let's read this. This says x belongs to the interval from, and that's -3, including -3, all the way to infinity. So -3 to infinity. We're including the -3 because of the square bracket here. We're including the -3. If it is closed circle like it is here, you will put a square bracket to represent -3. Infinity will always have a rounded bracket. And if the circle is open, you would also use a round bracket. Now the concept of infinity never ends and can never have a square bracket. Because it never ends, you can never have a square bracket. Okay, moving on. Given x belongs to real such that x is less than 2, graph and write in interval notation. So you're to graph this and write it in interval notation. So we need to create a number line with 7 ticks. And with that 7 ticks, you number them. And making sure that 2 is located, the number we want is located somewhere in the middle. Now, do we put a round open circle at 2 or a closed circle at 2? Well, looking here, this tells us there better be an open circle. Now this is saying x is less than 2. We need all the numbers less than 2. All the real numbers less than 2. That is going in this direction. So we write the number line such that the line is going in this direction. These are all the less than ones. The less than numbers. Interval notation, we want to write this. Remember that it is not a necessary component, but it is a great way to understand this. That is, x belongs to real from negative infinity. So the leftmost number is negative infinity. This is going towards negative infinity. So we start with negative infinity. And we go all the way up to 2. So what do we have here? The interval from negative infinity to 2. That represents interval notation. Moving on. Graph and write the following in set notation. To write this in set notation, we should first look at this in terms of the number line. Graph, 7 ticks. And we make sure we include from -6 to -1. I'm doing a little bit extra so that there is blanks on either side. Why? Because I want to know only the numbers from -6 to -1. That is, at -6, we will put a, look at the type of bracket, that's right, a closed circle on -6. Then we will put an open bracket at -1, an open bracket at -1, and a line in between. So what do we have? From -6 to -1, closed at -6, open at -1, and folks, here is your number line. We've graphed it on a number line. Now, we're going to write this in set notation. Set notation begins the exact same way, folks. It's like the beginning of a fairy tale, once upon a time. So we started off with set brackets. X belongs to real, such that, so once upon a time, such that, that's right, x is between, so now this is going to be the hard part. It starts with -6, it ends with -1, x is between there. So looking at this, this is how you start it off. X is between these numbers. That is, starts from the left, -6, from the right, -1. -6 lower, -1 higher. Now, x is going to be bigger than. See how the opening is bigger, so you read it backwards. X is bigger than or equal to -6, and x is also less than -1. We're not including -1 because it's an open circle. So x is bigger than or equal to -6, and x is less than -1. And we close the bracket. So this is how we represent an interval between two sets of numbers. Okay, moving on. Express the graph in set and interval notation. That is, express this in set and interval notation. So what is this saying? This is saying, let's look at all the numbers that are less than -2. Or we jump over here and say, let's look at all the numbers greater than 3. We need to express this in set and interval notation. In set notation, x belongs to real such that x is less than -2 or x is greater than or equal to 3. Now we can use, instead of or, we can use a U symbol to represent or. So a U or the word or are both acceptable. We have 2 pieces on the graph. We have 2 pieces in set notation. In terms of interval notation, I will show this to you, but this is not a requirement. That is, x belongs to from negative infinity to negative 2, round bracket, or square bracket 3 to infinity, round bracket. So again, round, round, square, round. And make sure that you fit this in like this. And you can use the U symbol or the word or in interval notation. Okay, next. Let's look at another number line. Let's look at this number line. What is this number line saying? Well, it's saying it's all the numbers but this number. That is the strangest thing ever. That's right, all the numbers except this number. Well, how do you write that? In set notation, we write it as x belongs to real such that x does not equal one number. That is 1. It equals everything else, folks, just not the number 1. So, interval notation, a little bit harder, folks. You can look at this, but it will not be assessed until you're in grade 12 for interval notation. Set, that is an expectation. That is, x belongs to real from negative infinity to 1, round bracket, or from 1 to infinity, round brackets as well. The reason why it's round brackets is because we're not including the 1. Okay, moving on. In this course, as I mentioned earlier, we are going to be looking at domain and range using set notation only. Interval notation is just an easier way to look at. So, our next video is going to be dealing with domain and also range. So to determining not just the domain, but the range as well. Alright folks, that's the end of the video. Have a numerical day.